Kia ora koutou. Welcome to the Otago Energy Research Centre seminar series. As you probably know, the Otago Energy Research Centre is really keen on this idea of living labs, where both the researchers try to apply their ideas to the living lab, which is the university, and we learn from the university about what the university is doing and gather data and things that we can explore new opportunities at the university. So it's my great pleasure today to welcome Shane Jenkins, who's our speaker for today. So Shane is is part of the University Property Services Energy team, and he's the Energy and Buildings Control Manager. So he's going to tell us about some new approaches to smart buildings and building management systems analytics. So yeah, over to you, Shane. Thanks a lot.
Thank you. Kia ora koutou. So I'm the manager of Energy and Building Controls at the newly formed Property and Campus Development Division. So we've been here since the 4th of September. It's a merge of property services and campus development. We're responsible for the built environment of the university, so the buildings and the systems within them. I guess a little bit about me for people who don't know. I've worked here for 17 years. Part of that I studied for, did a BSc in energy management. I've been doing this job for about 4 years, but my background is industrial process control and working in various industries like the meat industry and the dairy industry, doing some R&D and streamlining their systems. I'm talking about our analytics project, which takes data from our BMS, which is our building management system. Get rid of Yep. So a little bit about us. We're a really small team. There's me, an energy analyst who's based in Christchurch, and she does our data analysing. And we actually have a vacancy for an energy efficiency officer. We're a really small team with a really big job. We manage a very large portfolio. Energy budget's about $22 to $25 million a year. And our focus is on the sustainable operation of the university. And that's not just sustainability from the point of view of environmental sustainability. That's making sure that we're still here in another 150 years. So making sure that we future-proof the operations of the university. We're pretty busy. Our business as usual activities, they take up most of our time. We see lots of opportunities. We don't really have a chance to investigate them as well as we'd like. So a little bit of background about our building management system. It's one of the biggest and most diverse in Australasia. Part of that is because we've got quite a diverse building stock. We've got buildings that are 150 odd years old. We've got BMS systems that are 30, 40 years old. And we've got some that were brand new yesterday. We have about 100,000 data points on our BMS across three separate servers that are all linked together. They're all hosted in our IT data centres. So the building management system monitors and controls heating, ventilation and air conditioning. It also links to lighting systems, access control, AV systems, things like that. The university set some pretty ambitious targets to manage and reduce energy consumption and carbon reduction. Now more than ever, that's really important for us, reducing our operational costs. And we've got, like I said, we've got 100,000 points on our BMS. We've got a whole heap of data. We haven't really done much with it up until now. So we sort of thought, how can we maximise the potential of our BMS? In 2019, we were lucky enough to be given the opportunity to develop a business case on making our buildings a little bit smarter. So part of that, we had to upgrade our BMS in all of our significant buildings. We integrated the BMS with room booking systems. So a room like this that's scheduled, the BMS turns the ventilation on automatically. It was a game changer. Like, it's a small part of the project, but it's massive savings. And during COVID, it was a game changer as well. We didn't have to manually enter bookings for rooms. We integrated the BMS with Internet of Things devices. That wasn't as easy as it sounds. Our IT department weren't amazingly pleased with the idea of this whole Internet of Things being led onto our BMS system. And we utilised the BMS data more effectively through analytics. So you might be asking, why did we choose analytics for this project? Well, some of the results that we were told we would get from case studies are 18% total building energy reduction on average. We thought we were doing a good job, so we went for 15% in the first year, and then we assumed that there would be diminishing returns as we fixed the low-hanging fruit, and 12% for the year after that. We got 15% in the buildings for the first year that were in there on average. So we're pretty pleased with that. 60% labour savings on reactive HVAC maintenance. So that's not a reduction in the amount of maintenance we have to do, but it's a reduction in the cost of the maintenance. So we got to choose when we did the maintenance. We saw a piece of equipment that was starting to fail, and we could fix it before it broke, before we had to fix it in the middle of the night or shut down a lab or something like that. So a little bit about our vendor that we chose, Coppertree. They did controls, building management controls for 40 years. They've been doing analytics for a long time. You can see it's 2,000 buildings, 4 continents, 42 million square metres of building stock. The key thing for us is this ROI. 2 years, that's pretty amazing for anything, but most of them are in weeks. We're not quite in weeks, but definitely 2 years. We were one of the first people at the University of Otago to implement it on a large scale. So other universities and other government areas like councils and things like that, they used a little bit, but they didn't use it as holistically as we do, and they didn't use it for their day-to-day operations. The good thing about Coppertree was they're actually our local control system provider as a vendor for them, as an agent for them rather. So we get local support, which is pretty big. So a little bit about data analytics. It's a process of examining data sets to make conclusions, and it's widely used in IT and finance and manufacturing sectors, but it was never really used in building management, mainly because the systems were proprietary, so you couldn't get the data out. If you had a building management system, only the BMS people could get that data, only the BMS people could use it. And you couldn't connect your BMS to your lighting system. That wasn't a thing. And in the last 5 years, they've become open source, and so there's been an opportunity to send the data into an analytics system. So how does BMS analytics work? So we have our existing BMS, and we have our main server and our controllers, and they're all connected to the field devices, and we have our heat sources, and it's just pretty standard stuff. We have an edge device on campus, so all of the data, those 100,000 data points, they get sent through the network, through an edge device, off-site, through a firewall, and then they get sent to, in this case, Kaizen. So that's the brand name of the fault detection analytics package that we use. So basically, that takes all your data, has some algorithms, has some rules that we put in, and it uses machine learning to generate insights. So if you have some equipment doing a particular thing, which we'll go through later on, it will give you an insight and say, this is doing this, you should maybe do this. So it's pretty powerful, and obviously we get our insights and our alerts, and they're online, so you can get it on your cell phone or whatever. I guess the thing is, we use machine learning and AI, but it's the good kind of AI. So it doesn't go out into the world, it only stays in their data set. So it uses verified answers. So it knows that an air handler works like this, and it measures data in those, 2,000 sites, and it doesn't go out to the internet. It doesn't look on YouTube or Facebook and say, maybe we should do this. So it's like a garden that's being looked after. There's no weeds in it, and all the information is really good. So analytics provides some valuable insights. Systems running outside of schedules. You would think that would be pretty easy to pick up, but it's not, because most of our schedules stop when people aren't here. So we don't know if a system's not running. During COVID, we actually found a lot of systems that were running, even though we thought we'd turn them off. So that was quite useful. Manual overrides. So there's a lot of people who can access our BMS. There's a lot of people who fix a thing by turning it off or turning it on and leaving it in manual, and the controls can't do what they need to do. And analytics picks that up. Incorrect implementation of programs. So that's really where you have a room and it's designed to do a thing, but it's not quite doing it. And it might be because the code hasn't been written properly, or it might be because the room's changed use, and analytics can look at the data points and say, well, this isn't working as it should do. Deviations from system design. So that's kind of what I was talking about just then. So change of use, we do that a lot on the university because we own our buildings for so long. They go through several different iterations of what that building does. So a lab might not be a lab in 5 years. It might be something else. It might be a teaching space. Simultaneous heating and cooling. Again, you would think that's pretty simple and pretty obvious, and why don't we pick it up? In most cases, the only way we know there's a fault is if someone complains. And if your room is at 21 degrees, you don't complain. You don't know that the heating valve was passing a little bit and the cooling valve has come on to maintain your room at 21 degrees. You just see your room at 21 degrees. Analytics finds that. Faults with valves and dampers, such as leaking and hunting. So that goes back to kind of what I was talking about before. It sees the data. It's like, why are you heating and cooling at the same time? Maybe your heating valve or your cooling valve are passing. Big one at the moment is air quality. So we can see the air quality in spaces. We can see what the ventilation rates are doing, and we can examine how they recover. Analytics can keep looking at a building after we've all gone home and make sure that it's actually doing what it should do and that it's recovering. So the project, it was a project that we started with. So we thought about different ways of how we would analyse the effectiveness of analytics. So we had some different scenarios, some different things we were looking at. Buildings with really, really complex systems and high energy use and long hours of operation. Buildings, we have a lot of buildings with multiple energy sources. So some have electric heaters and a boiler and another type of heating for backup. And we have a number of buildings with performance issues that should work properly, but they don't. And we have high energy use them, and we don't really know why, and we don't have the time to investigate it. So these are the buildings we chose. You can see here the top three: Mellor Labs, Dental, and ISB. They're obviously pretty mission critical for the university. ISB is open for a long time, lots of hours, lots of people in there. Dental building, very, very energy dense, but also mission critical. We need to know if rooms aren't performing. And Mellor Labs is very similar, very energy dense, complex systems, pressure gradients, making sure that all the rooms are doing what they should. OBS, it's predominantly electric, so any savings we can make there are good, especially if we can make some savings early in the morning when electricity is expensive. And William James building is one of those buildings that has 3 different energy sources. So it has a CHP, a combined heat power plant, has a biomass boiler and electric heating. So making sure that those systems aren't fighting each other, really important. St David 2, recently renovated, open plan office, surprisingly high energy use for what it is. And the LFB building, or it's the med school. The whole thing's kind of been built ad hoc, old, inefficient building with labs put in the middle of nowhere. So just trying to get our head around how those buildings are working and where we've got problem areas and what we need to focus our resource on is very useful. So that's why that was chosen. So here, it's a typical dashboard from our analytics. So this is from the dental school. So I'll just go through a little bit of the sort of things that this shows you. This was taken after we'd fixed a lot of the problems, but you can see there's still 50 odd faults. But those are kind of noise faults. So they are ones where we didn't quite get our rules set up properly. And I'll explain that in a minute. So we'll just go through the dashboard. So typical dashboard, building location. This whole platform can do a portfolio view. So this building location is quite powerful and quite useful. So the next thing is the type of insight. So we have faults, we have energy insights, golden standard. So a golden standard insight is you have an air handler and this is the way it should work. And we take every air handler that we have and compare it to that and see how our air handlers are performing or our piece of equipment. Infrastructure is just the edge devices, making sure that our network is talking as it should. And integrity KPIs. So those are things like we have it set up for measuring carbon and we set our KPIs that we're looking for. Like I said, this is pretty early on in the piece, so we've kind of focused on our energy and our faults and less so on our KPIs because they come once we fix all of the big chunky problems. So this line here is basically an aggregate of all of the stuff below it. So it's the total potential savings. If we fix the faults or the insights that show up, this is how much we could save. It's a trend. It's not 100% right. Like I said, we have multiple energy sources and electricity isn't a consistent price, and we've had to make some assumptions and some averages, but it gives us an idea of what we could potentially save. And this is a more detailed list of the faults and the potential savings, you know, and you can click on those insights and jump to another screen, which I'll show in a minute. And infographics. Everyone loves infographics. You know, you see a red exclamation point, you know, that's something you need to look at. And we set those priorities. So it's a very useful tool for actually focusing on the things that are important. So this is a in-depth look at one of the insights. It's actually from the second one down in the list because I thought it was a little bit more interesting. So this is a chiller cycling more than expected. That comes back to the integrity KPI situation or the gold standard rather, where we know how a chiller should work and this one's not doing what it should do. So you kind of think, why is a chiller cycling more than expected? How are we going to get energy savings from that? Well, every time a induction motor starts, it uses 5 or 6 times more energy than it does when it's running at full load. So if you're cycling it more than you should, you're using more energy you should. And it's also, it's hard on the gear. The compressors are starting and stopping, contactors are pulling in. But on top of that, we like to have a nice straight line, not a line like that. And in a dental school, we need to know that our environment is consistent. So when your chilled water temperature is wandering around like that, that means we have to modify our heating loops and our cooling loops, and all of the system works harder to maintain a consistent temperature. So like trends, super helpful. So our trades guys use this as a tool. So they can go in and say, that's not right. Where's the problem? We get all of the trend data in there. They can see if it's happening at a particular part of the day or part of the weekend or something like that. So it's a really useful visual tool. The bottom part there, it actually, like I said before, it has machine learning. So it recommends some solutions to the faults. So it looks at that and says, have you checked your temperature sensor? in the thousands of other chillers we've seen that have been reacting like this has been a faulty supply temperature or a faulty return temperature. Or maybe your chiller's too big. Maybe you're trying to cool your water too cold. So have a look at those things. So the way that this system gets its data is when we go to a job, we log this job, we write down what we've found. So we basically feed back to the analytics. So we'll click on that. We'll say we found the temperature sensor had failed, and so then that feeds into helps with the machine learning. Or we might go in and say it was really hot, so the chiller couldn't deal with the temperature, and we live in Dunedin, and lots of other reasons. So analytics is kind of, in building management systems, we like this idea of continuous commissioning. So we don't build a building and put a BMS in and leave it. Like I said, we own our buildings for a long time, and we're constantly upgrading them, we're constantly changing them. We need to make sure that we're constantly making sure that all of our systems work how they're designed to work. So there's automated tools. So we have reports that the analytics can write for us. It lets us know if, like, we can have manual override reports. We can have reports on energy consumption. We can have reports on carbon. If we're particularly interested in an area, we can set up a custom report for that. And those reports can go to all of the different stakeholders. So it's just not me and my team who use it. Our trades guys use it. They use it for generating work requests. So they'll see that a filter needs to be changed and they'll write a request. Our facilities management team use the data from analytics. So it really gives us a full picture of how our buildings and how our equipment is performing. New building commissioning. So when we build a new building, we kind of take it as written that the consultants knew what they were doing. And we assume that the contractors built the building as it was specified. And we assume that it's going to work as designed. And for the first year, the building is maintained and operated by the contractor. It's a defects and liabilities period. So we occupy the building and we're users, but we're not maintaining it. So we don't get a lot of we don't get a lot of information about how it's performing for that first year. And the first year is where all the gremlins are. The first year is where we find all of the things that aren't quite right. So having analytics in a building from the start means that we see how all of those systems are performing. It's like having an independent commissioning agent there on site all day, every day for the whole time, but they're independent. They're not contractors and consultants who are trying to just keep the building going until the anniversary of its practical completion, and then they give it to us and then we try and deal with the faults. So, yeah, that's essentially what I'm saying is it makes sure that the building is working as designed. It's a really useful tool. Well, we hope it's going to be a really useful tool for holding consultants and designers to account. So it's also really helpful for controls. When you build a new building, you write your specification, you write your control program, but you've got no background of how that building's work. You don't know how it's going to react to a sudden change in temperature or a sudden change in weather like we've had now. So analytics running alongside will help us actually see how the buildings are performing. So another key thing with analytics that's quite important and quite exciting is the whole education point of view, like Michael alluded to, living labs, very, very important. Property services and the energy team, we've had a long association with energy labs. It's something that I actually quite passionate about. I think it's really important. Having been a student here, it's something dear to my heart. So we collaborate already with students from various programs. We work with the Office of Sustainability, the Physics Department, Information Science Department. They use our data. We have summer students We have people from OERC working, using our data as well. And we sort of help with mentoring and data from our various systems, whether it's our energy, our BMS systems, our electricity metering systems, our water metering systems, and our finance systems. But the addition of analytics, it's another level of data that we can provide. So kind of as a building block. Oops. Yeah, I changed that. So I thought I was going to get this wrong. So property and campus development, part of the Energy Living Lab. We all know what it's for, but it's really important, you know. It's constructive collaboration between academic and operational staff, but also students in the wider community. So it's actually really important. One of the really, really good things about our analytic package that the other ones that we looked at don't have is you can write custom algorithms for any scenario. And there's also a massive ecosystem of rules and algorithms out there already. So if you have a particular problem or a particular question, there's probably a rule or an algorithm there for it. But if there isn't, you can write one and you don't need to be able to code. So it's basically, you just take a block. So, you know, a temperature sensor, a return air sensor, a room control, room variables. You can put all of those things together, sum it up, see what happens and get some data. And the amazing thing about this is you can do whatever you like. It doesn't affect the BMS. It doesn't control the rooms. It doesn't change the environment. All the data is one way. So we send the data out, someone writes a rule, they go onto the server or get a report. It hasn't fed back into the BMS and made any changes. So, yeah, there's no limit to what you could write a program for or a rule for. The project's been pretty successful, very successful. It's found a lot of things that we didn't. It's met all of the requirements that we thought. So we've saved energy, we've saved reactive maintenance. We actually found lots of equipment that we thought was connected to the BMS that wasn't connected to the BMS. So an example is a chiller on the roof of the ISB that had been running happily for 5 years with a connection at one end and a connection at the other end, but no wire in between. So that's probably paid for the first year of analytics alone. But due to the success of that, and it's kind of now our business as usual tool, our trades guys use this. They'll get a request, and the first thing that the controls text will do is look, and if it's in one of the buildings, look and see what analytics says. But we're putting it in some new buildings. Rangihiroa, newly completed, not particularly complicated, long hours of operation. But the key thing about this is it's going to be our first installation on a brand new facility. So it's going to be our first chance to test how it is for the idea of an independent commissioning agent. It's going to be our first chance to actually see if we can find some problems before we inherit them at the end of the defects and liability period. We know that it's going to work because Auckland University, all of their new builds, they have analytics on for a new build, and then they take it off. So after a year, they take it off, up until recently. So now they've started using it like we use it. The Eccles building, so it's a modern building, finished pretty recently, has a really high base energy load, and the thermal energy is supplied by an LPG boiler. So any efficiencies that we can make in that, they have a direct reduction in our carbon emissions. But on top of that, we don't want that LPG boiler there anymore. So we want to have the building as efficiently as possible before we choose our next energy source, because we don't want to overbuild like it is at the moment. Currently, the boiler is twice as big as it needs to be, and we want to make sure that the solution that we put in there is the right solution for a building working as designed. So that's going to be quite exciting to use that as a tool. And the Plaza building. So it's a teaching space at the moment. Built down at the, for those who don't know what the Plaza is, it's the old Foundations Pathways building on the end of the stadium. It's a teaching space, but we're converting it into an open plan office building for 250 operational staff, including property services, campus development. We're changing the use of that building. We don't know how it's going to perform having it fully loaded like it's going to be. It was never designed to do that. Analytics is going to help us find the pinch points. It's going to help us find the areas that are not working as they should before people start complaining. Because, 250 people in a building, we're not going to be able to maintain it like we normally do. We're not going to be able to purge seminar spaces so that we can cool them down before students go in there, because there's going to be someone in there all the time. So we're really focused, well, I'm particularly focused on making our buildings smarter and more energy efficient. So Copper Tree, that we're starting to unlock the potential of our BMS, and that's helping us reach our energy and carbon reduction goals. But the really important thing about this project was a really good starter. We put a lot of enablers in. So like I mentioned before, we integrated our room booking system. I've been trying to do that for 10 years. Now we can do that. This idea of integrating systems and sending data to another system and getting data from another system, analytics has made that more possible, and the data from it is more useful. Internet of Things, integrating that's another game changer for us. We're going to use that for spatial utilization, and we're going to be able to feed the data from our spatial utilization into analytics, because analytics doesn't really care whether it's a heating system or a room booking system or a space management system where you have a sensor under this table to see if someone's working here. It's just data. It's just ones and zeros. So all of these different enablers that we put in, we're going to feed into analytics, and we're going to get even more benefit from them, which is obviously paving the way for a greener and more sustainable future. And like I said before, one of my prime directives in my job description is the sustainable operation of university. So yeah, it's got to be done. So we were one of the first universities to do this on a large scale in lots of different buildings, and that was an interesting exercise. So being first meant that we didn't know there were no benchmarks. It was hard to set some realistic expectations. All the case studies said 18% energy reduction and 60% reduction in reactive maintenance, but we thought we were doing a good job. So did we really put 18% in and then not achieve it? How do we know what's a realistic benefit to get out of the system? The other thing is we really didn't know what we didn't know. No one had done analytics on our building management system. We didn't know the right questions to ask. We didn't know the right information to provide the vendors. I mentioned before there was all of those faults. A lot of those faults were where we sent the data to the vendor. We didn't tell them that we don't do humidification or dehumidification. So a lot of those faults are saying, your room's at 60% humidity. You should fix that. We can't fix that because we have no way of controlling it. So now we know that when we send the data away for these new buildings we're doing, we say no humidification control, or this is a lab and this is the mode that it operates in. So that's really important, because that means you get really, really good insights right from the start. Collaborating. There was a lot of people involved in the projects. ranging from, there was project steering committees, project control groups, there was finance were involved within it, strategic finance, IT. We needed to make sure that we were telling everyone, we were communicating. So it was really easy for me to see the benefits of it. But sometimes it's quite hard to convert energy manager into finance, into facility manager, and into project. So, and the other thing was actually having some tangible benefits, measuring the benefits of the project. With energy, it's quite easy because a reduction in energy is a reduction in dollars. But some of the other things are not quite as easy to quantify. So the whole maintenance thing, it's really hard to quantify the savings in that because they're not instantaneous. You make a building more efficient, the next month's energy bill is cheaper. You reduce your maintenance, that might not show through until the next year's budget where you go back and look at what you've done. So actually finding a way to report the benefits that is, transparent as well is pretty important. So there was a lot of people involved in this, the senior leadership. So the whole project was a big enough value that we had to go to VCAG to get funding for it. So it was supported by the coup. It was actually his idea, the whole smart building initiative. Anybody who's heard him speak will know that he's big on energy and space. Obviously, Dean, who was the Director of Property Services then, Head of IT. So IT infrastructure, massively important with this process, with this project. Was the first time that we've really tried to use IT we've had IT support our building management system, but this time we wanted to do more. So we did things like API. So using APIs to talk to different systems. So IT were pretty important for that. So there was lots of project team members, trade services, Set Point Solution are our control system people. So they're agents for Siemens, which is our BMS system. Tree, obviously. And we had a pretty amazing project manager. So yeah, she always gets a big acknowledgement for me because without her, I wouldn't be here talking about it because it wouldn't have worked. So the project was a success, so much so that I went to a tertiary conference and we were entered. We were finalists in excellence in innovation, technology innovation, and we kind of won. So I didn't realise how much of a big deal it was. I didn't realise that it was actually a competition. I thought I was going to the conference and I was going to talk to some people about our project. And yeah, we got the world's heaviest trophy. So that's it. I think it's not too bad. So yeah, I'm happy to answer any questions.
That's really interesting, the results, but also thanks for sharing all the sort of practical issues you've had in implementing this sort of thing as you went along. So any questions? I'll just stand over here just in case I can. You stand over here, Shane, just so I can see if there's anything online. Cool. No questions.
Hi, Mike, I've got a question. It's Robert Holt, Callaghan Innovation here.
Oh, hi, Robert. How are you?
Yeah, well, thank you. Hey, thank you very much for an excellent talk. Really enjoyed that. I love the the model that you can actually put a what if in there. Does it inspire you to do more heat recovery systems? Because it looked like you could do the what if impact of heat recovery from all sorts of ways. So
yeah, it does.
Is that a future extension?
Yeah, I mean, there's so many. I've got a pad with so many ideas written down on it, and the start of so many rules and algorithms. But yeah, it's a starter. It's definitely a starter.
Great.
Just sort of a follow-up to that kind of question. You mentioned at the start you and your team are so consumed with business as usual.
Yep.
What are those top 3 things that you wish you had sort of the time to investigate further? And is that a potential research project or student project or something?
Yeah, heat recovery is actually a big one. Sam knows that that's something that we're talking about. I guess it would be really good to use analytics to actually deep dive on a building. Kind of really don't look at buildings in detail. We have a medium temperature hot water system on campus. It would be really good to model those buildings. That's my next big thing. Our next big thing as a university is what happens when the energy centre down the road closes, when the hospital closes. We need to be thinking about how we're going to heat the university going forward. So honestly, that's my top 3 things right there: the energy centre replacement. How do we get the right data to make sure we get the right solution? So that's a PhD, not a research project.
Anything else? Sam, yeah.
So, I've actually answered this already, but with
Do you mind speaking up? So they can hear you online?
with the data analytics, you can see if there is something that has on-off control, like the chiller, give you a suggestion like, oh, go check out the temperature sensors and different kind of things. Can it get down to the detail of there's not an on-off control, but there's something funny with a PID controller? Can it get to that level of detail and then you can tell set when you look at it?
Yeah, it does. It does. But it's only as good as the data that you put in. So that's kind of what I was saying before. We need to say when we send away the data for our new buildings that we have, this is the controls. So we send away our functional description now. Before we didn't have that. So yeah, it will do that.
Yeah, because it seems to me that the AI component, when I first heard AI, I guess I was thinking of something more sophisticated, but what it's just doing, and I don't mean that in a good way, I mean that in a bad way.
Yeah.
Because if you know AI can hide things, I think, but it sounds to me like it's checking against normal behavior most of the time.
Yeah.
And it has a knowledge of what normal behavior is, and so it just goes, well, it's not normal. Go have a look.
Yeah, exactly.
Which is sort of like a very low level sort of.
Yeah.
But because you're worrying about so many buildings all the time, that's for your particular purposes, that's all you need.
That's right. And I mean, like me, most of you would have been looking at those insights that we get and gone, those are common sense. But the thing is, we can't sit in front of a computer watching it all the time. So having that data coming back, and like it's a finite set of data that we need. We're only interested in how these systems perform. We're interested in how they perform in different climates and different weather and stuff. But we don't really care about what happens if you do this weird thing that's a new thing, because we're not going to do that. So yeah, it can be a really discrete set of machine learning that is, it's just basically data analyzing rather than machine learning.
Yeah.
But people like to hear AI and machine learning. So
you mentioned briefly that it analyzes comfort, air quality. Sorry, what's the?
So it does it from the sensors in the BMS. So it knows we have air quality sensors in some rooms, but it also knows. I didn't mention it in the presentation, but it has things called virtual meters. So it looks at a fan system and it can go, this is the fan curve, these are your sizes. We send all that information. So it can work out how much air is in there. And if we have, hours of operation and we send our room booking data, it can build a picture of who's in the room and it can know, we can bring the systems on earlier to make sure that they purge the bad air out. So we don't book a lecture theatre for 1 o'clock and 3 o'clock and turn it off at 1. We run it with fresh air for an hour or so to get rid of the bad air. So it kind of does that calculation. But like I said before, it's only as good as the data that we put in. So we need to tell it that there's a CO2 sensor, and we need to tell it the pump curve and the fan curve and the duct size and also our functional description. And like all of this stuff, it's basically trends. It's not 100% right, but it's going to tell us that the space at the end of the day, the air quality is not very good, and the fresh air fan's been going flat out. So maybe your fresh air fan isn't big enough.
Sam,
Sorry, this might be a bit too technical, but say if you supply a fan curve, you have to supply a system curve as well, so you kind of seek and make sure that into instability regions and things like that.
No, we don't do that. We could,
but some idea of the system curve is need to know.
Yeah,
that dictates the fans and so.
Yeah, I guess we haven't in the past. Certainly something that I could ask about. This is kind of baby steps for us. It's pretty unusual for property services to actually be sending fan curves to anyone, to be quite honest.
Yeah.
When we do our designs and things like that, we kind of just go, these are the fans that we've used in the past that we know work.
Yeah.
And we rely on consultants to choose the right one.
So does it mean that you've had to collect a lot of basic information as well, that you have put it all in the same place, that you?
Yeah.
I'm just thinking about really simple things like floor area and
Yeah, so we have that data, property services have that data, but the whole idea of having that data in a useful format that lots of different systems can look at, that's been a challenge for us. Before we chucked it all into our drive, and somewhere if you dug around you could find the full square area, but we weren't very good at tagging data, and we weren't really good at putting data in the right place. One of the projects that property services and campus development are doing is an integrated work management system. So that basically takes all of the property data and puts it in a single usable format. It's like a data lake essentially. So, the energy system can go in and look at that floor area, and analytics will be able to as well, and preventative maintenance and all of that.
So how far are you along in kind of getting that information into the
we're implementing into the BMS.
Into the system, I guess.
Yeah. So the project is being implemented at the moment. It's due to be finished May next year. So once we do that, it's just a matter of building an API for analytics to get the data, or for the IWMS to send the data to analytics, really, and say, this is the area that you're looking at, these buildings.
It sounds like a fantastic playground for students.
Yeah, it does.
Lots of things.
Yeah. I'm not part of the IWMS. It's called Property Plus. I'm not part of that project, but it's going to be massive for us.
Jan, are there any other questions? I can't see. I only see when people talk. Any other questions from online? I just want to see the participants. Yeah. Okay. Yeah. Cool. Oh, lots of people online. Okay. Any other questions? Burning up.
What's the difference between what Coppertree does and what Kaizen does?
So Kaizen is a part of Coppertree. So that's the brand name of. So Coppertree do a whole bunch of solutions. So they do an energy management solution, and the part that we have is fault diagnostic and fault detection and diagnostic. And Kaizen, I think it's a Japanese term for continuous improvement or something like that. So it's basically the part that we use.
So I just have a question about, I guess, the future. When you, at the moment, a lot of it seems to be one way. So you're doing analytics on information coming in. I imagine you want to get to the stage where you can do smart control back. With things like, I don't know, thinking even further down the road, demand response and things like that. Is that
so? It can do that.
right?
The analytics can do that. But I guess it comes back to that whole, making sure the data's right. We might not necessarily be doing things the way that someone else does it. And, it might be that analytics goes, oh, you got this happening, you got heating and cooling, and it might not realize that we're trying to do agricultural dehumidification, and it might stop us, we might turn that off, So we need to make sure that we have the right data there. But yeah, 100%. Even having rather than us having to manually go in and interrogate the system essentially to get an insight. I mean, it sends reports, but actually sending a report or a fault straight to our IWMS so it can generate a work order, and then using that information to then also change our preventative maintenance schedule. So, the fan coil, the filter blocked after 6 months, but it's on a 12 months PM. So we bring that PM back and it does that all automatically. That's the dream. But we're kind of baby stepping it.
Interesting.
Any sort of insights between potential disconnect between smart buildings and dumb users that are highlighting how people aren't behaving the way the system thinks they're behaving, and so that's sort of generating flags?
Yeah, all the time. Yeah. I mean, we knew what was happening. You walk past buildings and the heating's on and the windows open all the time. And also people changing the use of a building, changing the use of a space and not telling us. There is a big disconnect. But we have to be pretty careful about how we
It's such a diverse, complex system.
Yeah, I mean, even my job, looking after people's thermal comfort and stuff, nobody is the same. So nobody's going to use the space the same. And analytics essentially makes an average of it. So, there's a bell curve and there's going to be some outliers doing crazy stuff wherever we look.
You mentioned that the AI that the system uses is kind of like isolated from the regular internet data. But when you put in your data, can it be shared with other people using the same service? Like something that it had learned from Otago, the people in Auckland, if they use the same service, can they?
Yeah, exactly. That? Yeah, so it gets its data like that, but it doesn't go looking outside their ecosystem, if you like. So it doesn't go, oh, some guy on YouTube's built a better heat pump, maybe we should use that data, because it's unverified. So the key thing about analytics or this package is it's only as good as the data that we put back. So when we find a problem, we put tags in and say what we found. So like the machine learning says the sensor might be broken. We go in and say the sensor wasn't broken, but it wasn't calibrated right, or someone had installed the wrong sensor. So then it keeps that data, and that's used for someone else's machine learning insight.
Okay, so I'm conscious of the time, so I think we'll bring it to a close now. Thank you very much for your talk, Shane, and we're really keen to hear, in a year's time where it's got to, because it sounds like it's definitely a learning process. So if you could all join me to thank Shane for his time. Thank you all for joining us online.
Thank you.